Hello again. I'm back again with my third video. In 1 week, this is a record for me. Man, well, I'm still doing this kind of case study thing with pig and sticks. I probably should look at some Atari games and maybe make up a different game, but for right now, it's probably good enough. For this particular one, I decided to take a look at a way to utilize more than one type of rendering API in a single application. This example is going to be fairly complicated because it involves using DLL files to basically swap out the renderer. So yeah, um, I made three different renderers, or three different DLL files, and wrapped up three different. Oh, sorry about that. It's in this folder. Uh, I wrapped up three different APIs that I can use for a single project, and they are OpenGL 4, Directory 11, and for laughs and giggles, I added in fixed function pipeline D Directory 9, which was pretty nostalgic. I haven't used Directory 9 since like 2012. It was a fun excursion trying to remember how to use that API. I miss DD Directory 9. It was such a simple API. Well, the other cool thing is that this example, which you can configure it and change it before you launch the game. Come on, load please. I'm gonna have to make this quick because I have to go do something with my family. We had to go pick up my younger brother from his job, and I had to get up early in the morning for my job in the morning. 'Cause finally, the snowstorm is over with. Alrighty, then let's see here. Come on. Making sure that my mic is not muted because I've ran into that mistake multiple times on the other channel. Oh, I need to post the name of that channel one of these days. Let's see here. Aha, caught that sinus issue. As you can see, this little configuration file allows you to set up whatever DLL file you want to use for this. Right now it's set to 9. Let's set it to Rec3D 11, which is the first one that we launched. So let's launch it. Come on. I clicked on you. So it's supposed to be rendering in Directory 11. It's running pretty well. As expected from this little pick and six clone. By next video, I'll hopefully have a different example game project. I'm gonna watch some Atari videos and just think of some ideas for a simple game example. And if you remember before, it shouldn't be wasting too much memory. So I'm gonna launch the task manager real quick. It's running at good old 8 megs of memory, which is a good sign. That means that the Directory 11 drivers are fairly optimized for this. So let's exit that. Let's change it to GL4. Come on, there we go. Relaunch the project. I don't know why it's loading up so slow. It could be the fact that I have several things open all at once and I'm recording a video. I had a break when I'm making a video. This is magical. Well, it's allocating memory. That's a good sign. Hmm. Good lord, come on. There we go. Man, that took forever. And here's the OpenGL version. As you can see, it's running at 71 megs. I don't know why. It has to be the driver causing that much memory. It has to be the driver. It's the only explanation of why you would need 71 megs of sysram or sys memory. I still don't know. And last but not least, we'll switch it to D3, D9 just to show that this works. And it just boots right up. What the heck, dude? How much memory you're wasting? 18 megs. I don't know why that was doing some weird slowdowns. Strange. Now you might be wondering to yourself, how are you doing this? Well, I'll show you. It's the magic of using DLL files and loading up the library at runtime. As you might have noticed, there's a bunch of function pointers. Each of these function pointers points to a function within the DLL files that is pretty much a public interface. And I basically load the library up using where are you? Using load library, and it'll load up the DLL file, and then I can get the function pointer's address from the DLL file using the get proc address function from the sys from the Windows .h file. And to just to show that I'm freeing up resources, you free it the DLL file using the free library function. The cool thing about doing it this way is that you can technically swap out the library with another library at runtime. Yes, runtime. That means you can do some interesting things with it, which I will cover that interesting thing in my next video, which I'll show you kind of a trick that you can do with DLL files in game development. It actually makes it very interesting. I just saw some flashing lights outside my window. Okay. Now, you might be wondering, so where is the rendering code? The interesting thing about using this method, the main application is kind of like a host application if you're doing it this way. So, if I can load it up, you go to the linker, look at inputs, there's no graphic libraries in this. There's only the SDL libraries that I'm using. However, let's go for example, this one, this is the DLL project for Directory 11, and I'll show you the file for this. Sorry about that, I had to burp. I don't want to kill you guys' eardrums. Alright, this is the DLL kind of source file for the Directory 11 version of it. Now, I didn't know you can actually do this, but you can actually initialize SDL in the DLL file and do a bunch of setups with it. So, for example, if you Direct3D, you don't need the OpenGL functionality. You just need to show a window so you can draw to that set surface. And you can actually implement all your SDL stuff in the DLL file, which is awesome. I did not know you could do this. I love experimenting. If you go further down, all the Direct3D code is the same from the previous video. I just copied and pasted it in just because I didn't want to waste a lot of time with it. So it should be the same code from that previous example. That does everything, including load up shaders, create the buffers, the raster division, all sorts of fun stuff. and the host application or the game itself will simply just reference these functions in it. You might have noticed that there's a dash in front of it, and in here there's no dash. That's because that's just a variable name. You can call it whatever you want to in the host project. So that's one nice thing about it. One catch that I found out about doing it this way is that you need to make sure you make a def file for exports because for some reason there is there's supposed to be a way to use like the C++ code to do exports, but for some reason I can't do it with these with the C with the source code routes. So I had to create this, which does it fine. All right, moving on. Let's go to the OpenGL version of the source code. Then I'll show you the kind of the funny D3D9 version. The OpenGL code is basically the same from the video before the last video. For the exception, I did a little change in the present method where I'll show you real quick, where I'm calling the SDL swap window from here instead of from the main loop because I want to make sure that everything is located in the DL file versus having the source file. I don't want any references to the main host program because I want to make sure to hide certain things. You could say data hiding or just functional hiding, whatever you want to call it. Encapsulation is another good word. Basically, it's a completely self-contained interface. The only thing you're doing in the host application is just calling these methods to do something. That's all you're doing. It's the pretty much purest way to do encapsulation in a lot of ways. And I'm actually thinking of ideas for when I'm maybe working on a 2D game engine or a 3D game engine using this method. Let's go back to, is this the GL one? Yep, it is. Yeah, it basically does the same thing. I load up the vertex fragment shader program. Same type of code from the previous one. It does basically the same thing. Now on to the funny one, which is Direct3D9. I'm not using Direct3D9's kind of shader approach. I'm doing this in fixed function just to demonstrate that you can kind of hide fixed function stuff if you want to. Shockingly, the code's way shorter than the other ones. You don't have to deal with many variables. That's the beauty of just dealing with a fixed function API like Direct3D9 used to be. I had to do some magic with this one because the matrix math with it, you have to pass the D3D matrix interface, so I had to do some REST conversions with it, which was totally awesome sauce. Let's see here. This brings back so many memories. I used to use Direct3D9. Actually, the first API I ever used was Direct3D8, which was many, many years ago. It was way back 2003 when I started doing graphics coding. So, oh god, it's 3 years from now. It's gonna be 20 years. It's crazy thinking in that context. Man, I've been doing this a while. It does basically the same thing, for the exception that you're not dealing with shader code at all. You're just changing states in the Direct3D9 state machine, and it works fairly well. Oh, I was trying to do some experimenting with vertex declarations just to see if I can split up the stream source into two different vertex buffers, but apparently I will have to implement shaders, and I'm not real sure how to do that without the deck the Direct 3D X9 library, which apparently is missing from the Windows Foundation. And I had to do some weird conversions with the colors because apparently, if you pass a D3D format, this kind of component with the alpha 8 or 8, red 8, green 8, and B 8, which basically means they're unsigned chars to this. The SDO kind of loading code for an image loads it up where the blue and red components are in reverse, so I had to do some RC conversions here to fix that issue. Typically, you would use the Direct3D X9 library to load textures, but it doesn't exist anymore, so I had to upload the texture myself and do all the stuff that I didn't know how to do, and I learned it in like about 30 minutes. Yeah. And doing the color operations, which I had no clue that you could do that. Yeah. This was a fun kind of little test just to flex on it. Um, but remember what I said before, that this way of doing it, if you're just using the load library function, you're basically linking the library at runtime. So there's a possibility of basically swapping out these DLL files at runtime. So the thing that you would have to do is recreate or release all of this, including everything. I'm trying to think how you would be able to do that. Because if I'm able to do that, dude, that would be sweet. Basically, you would be able to swap out whatever rendering API you want to use at runtime. Yeah, basically what I can do is swap out the library at runtime for the user, so they can configure options in, say, an option menu to basically do configuration changes. It will help. The reason why that I would, or if you're making an engine that you would want to do this, is for driver issues. It's due to the fact that drivers have a tendency to basically be reached. My experience with Vulkan with AMD drivers was horrendously bad. I've heard that from people who have NVIDIA drivers. That's not bad over there. That's the reason why bigger publishers or bigger game developer teams typically, if they're building an engine, they have the ability to swap out different rendering APIs at runtime. It's because of that issue. So this is kind of a fix for that issue. And it's a pretty cool fix. Like, it's kind of amazing that you can do stuff in C++, which has historically been a statically compiled language, and do stuff in real time. I think you might be able to do it with the POSIX kind of libraries, like trying to load up a .so file. I've not tested it, so I'm not real sure. But yeah, let's run this one more time. Yeah, I need to find a new example. I think I've overly used Pig and Six too many times for this. Oh well, at least I'm actually uploading videos. I've been feeling pretty good, even though I've been trapped at my house for like a week because that's god awful snowstorm that we've been having. And whew, that week was torture. Oh well, I guess I'll see y'all next time. Y'all take care. I'll see you in the next video. Take care, everybody.